Hello, this is Mr. Abbott, and I'll be doing a seminar in Pre-Calculus 12 on Learning Guide 1 and 2, Translations and Transformations. To start off, we'll be looking at some basic functions, because throughout the course in Pre-Calculus 12, you'll come up with a lot of these different functions, and you need to know the basics about them. So let's just look in. All right, the first one is a linear function. When we see the word linear, we know it's a straight line. And the very basic one is y equals x. So if we look at the standard form we did a while ago, y equals mx plus b, we remember hopefully that the m is the slope and the b is your y-intercept. So in this guy up here, y equals x, we know there is no b, so it's 0. And the slope, if you look in front of the x, there's a 1 there, invisible 1, so the slope is 1. So up over 1. And then we know there's a line that goes on like that. Now, let's look at the slope. Well, I just said earlier, the slope is 1. Because whatever's in front of the x is your slope. Now the domain. Well, if we look at that function, it goes forever to the right and forever to the left. So we know that the domain is x(ER). And the range is going forever up and ever down. So we know the range is y(ER). Now, when we look at vertical lines, we know a vertical line is straight up and down. So that would be, let's come over here. That would be anything that is going through the x-axis. So it's going to be x equaling a number. So let's pick 2. So if you looked at that, quick example. So I'll just draw the x and y axis. And x is going through 2, so right there. So it's a vertical line that looks like that. Now, if we look at a horizontal line, that's the line going horizontally, it's going to be y equals a number, let's say -4. So let's look at that. Okay, so we know the y-axis is up and down, so it's 1, 2, 3, 4, and it's a line like that. Okay. Second function here, we got the quadratic function. So now we're going to look at things quadratic, remember, is these U shapes. This is positive. Just remember it's got a happy face. And this is negative. Okay, this example, the basic one, is a positive because there's a positive 1 there. So I know it's opening up. And because there's nothing going on, the vertex is 0, 0. So we go 0, 0, over 1, up 1, over 2, up 4, 1, 2, 3, 4, 4. And there's my parabolic shape. Okay, standard form. Well, in this case, it's y equals a x minus p squared plus q. So that was what we did in grade 11. You'll notice that in a little while, these guys will become h's and this will become a k in the next functions. So, but right now we can call it p and q. All right, so the p and q tell us the shifting left and right, up and down. Okay, so domain of this function. Well, the domain, because it's going forever to the right and forever to the left, we know it's x(ER). And the range, it starts at the lowest point right there, 0, and goes all the way up forever. So it's everything greater than equal to greater than or equal to 0. Now the vertex is right there. Because there's no bracket and nothing outside there, we remember it's 0, 0. And the equation of the axis of symmetry, that's x equals p. In this case, it's x equals 0. Okay, now we're going to look at the square root function. The square root function, we have the basic one. So again, there's nothing going on, so it starts at 0, 0. Now if we just insert numbers, we can get the output. So if I make x 1, the square root of 1 is 1, so I know it's there. And if I do the square root of 2, I'll leave, because I don't know the square root of 2 exactly, or 3, but I know the square root of 4 is 2, so it goes to there. So there is a quick sketch of that square root function. Now we're going to look at the standard form. So y equals the a, stretching, bracket, x minus h. And that is all under the radical, because that's the root, plus the k, which is outside. Now, the a, this a right here, and we're going to deal with the b later on. That a and b is going to be in Learning Guide 2. That's going to deal with the stretching. For Learning Guide 1, we're just dealing with the h and the k. The stretching, the translations right, left, up, and down. Okay, so in this case, the vertex, or this point right here where it starts, or sometimes it's referred to where it ends, is 0, 0. Now the domain, because it starts at 0 here and goes forever that way, so it's x greater than or equal to 0. And the range is y, because it starts at 0 and goes upwards, greater than or equal to 0. Now the absolute value function. That's when you see these little bars, absolute. So to graph this guy, we just again insert values. So if I put 0, the absolute 0 is 0. If I put 1 into the x, the absolute of 1 is 1. If I put 2, the absolute 2 is 2. Now let's go to the negative side. The absolute of negative 1 is 1. The absolute of negative 2 is 2. So now we have enough points to get a graph. So there's what the absolute value function looks like. A very basic one. Okay, so again, we're going to see this format quite a bit now. And it's going to be x minus h. And remember the bars, because this time it's an absolute function, plus k. All right. Now the vertex, where it starts, is 0, 0. The domain, if you look at it, it's very similar to the quadratic. It's going to be x, XER, all real numbers. And the range is y greater than or equal to 0. Now we're going to move on to the cubic function. Well, the cubic function I call the snake. Okay, it looks sort of like that. Sort of looks like a snake slithering through the grass. Okay, so let's just put some points in to get a graph. So if I put 0 into x, well, 0 times 0 times 0 is 0. If I put 1, 1 times 1 times 1 is 1. If I pick 2, 2 times 2 times 2 is 8. Now if I go to the negative side, negative 1, so negative 1 times negative 1 times negative 1 is negative 1. And negative 2 times negative 2 times negative 2 is negative 8. So there's enough points to get a good sketch of that function. Okay, now let's look at the standard form. So again, like I said, we are going to see the same thing over and over. Now remember, this is a cubic function, so I put a little cube there and plus a k. Now the center is where it sort of rotates is 0, 0. The domain is XER because it goes on forever, right and left. And the range is YER because it goes forever up and down. The reciprocal function. Okay, reciprocal means 1 over. So when we deal with this, we're going to have some asymptotes. So I'm just going to deal with the asymptote first, because when you're graphing reciprocal functions, the asymptote is important and it's good to draw first. Now to get the asymptote, you deal with the bottom. So you look at the bottom, look at denominator. In this case it's x. You make it equal 0 and solve. Well, in this case it's solved. So there is my asymptote. So let's put the asymptote in. Okay. Now there's one at y equals 0, 2. You can't really see it because there's nothing out here. So there's a 0 out there. So we know that's going to be that guy. Now just to get some points to get a rough sketch, let's insert some values into this x here. So if I make x 1, well 1 over 1 is 1. Alright, and you know the asymptote, so it gets close and then it sort of turns and gets close. So it looks like that. And it's a mirror image over here. Alright, so there is the function graphed. Now, the standard form, again, we have 1 over x minus h and plus k. Alright, now the domain, it's going to be XER, except it cannot equal the asymptote, because the asymptote cannot be touched. It gets really close, but you can never touch it. And the range is YER, except you cannot equal the horizontal asymptote.